we're going to switch into the panel mode. So at this point, I'd like to ask Steve and Shiri and Jamie to join us and unmute your cameras. And so at this point, Andrew and I will just start by asking some questions, and then we'll also open up the discussion to the audience, either through the Q&A system or the chat as appropriate. So I'll just start with a question which was inspired by something Shiri mentioned, but I think it applies in most of the cases that were presented this morning. So Shiri mentioned in passing that there's a member of her team who actually has a background in optometry. Is that right, Shiri?
Yes, that's right.
So it just got me thinking, and so Steve mentions that, that there's a sort of historical curation element to what he's doing, and in the case of Stream, you can imagine that there are home repair professionals that are involved. I think there's a theme in what a lot of us are doing where there are real world users or people with really developed expertise that are outside of computer science that have a lot to offer, a lot to teach us. And I think to some extent this can apply to Jamie as well, although I think what Jamie's doing is very foundational. It's kind of a transformative, overarching sort of thing. But I wondered if any of you wanted to comment on the importance of the role of the non-computer vision people and how that shapes what you're doing.
I can get started. I mean, for Stream, it's crucial, right? So, like I said, our mission is making the world expertise more accessible. And so you have this trove of information that only some experts have. And typically that will be, they will have to come into your home to really provide for you to really get access to that. And so we think that, you know, when you combine AR, VR with that type of expertise, then you are really unlocking, you know, a like tremendous kind of value in the world. And so for us, our professional experts are so important, and we work with them on a daily basis to understand how to best support them, how to best build these AR tools so that they can feel like, you know, they don't have to travel to provide expertise. So I think that for us, it's really important.
Maybe Steve or Shiri.
Sure.
Yeah.
Yeah, I mean, computer vision is just a tool, right, among many other tools. And it's, you know, it's really about solving people's problems, and to the extent that we can do that, right? I think, you know, I think the session was really great, you know, from that standpoint, and that, you know, yes, devices, but also, you know, especially Flora and Shiri, and, you know, talking to sort of like, what are the things we can do with these devices? One in particular that I can mention that I have some experience with is that I did some work with VR and cameras. So we had this program called Jump, where we're trying to capture the world using stereoscopic 360 cameras, essentially trying to produce tools for filmmakers. And we started by just, you know, having a bunch of engineers, computer vision folks sit down and think, okay, what can we build using the technology that we know? And we built this thing, and we thought it'd be awesome. And then the first generation, when we brought it to filmmakers, they're like, well, how come it doesn't have a camera facing up? And how come the audio isn't great? And how come, you know, there's like 10 different things that we should have known when we started doing it. And then we realized, you know, no, you have to listen to the experts and figure out what they need and then build to that.
Yeah. Jamie.
Oh, I agree with what Steve said completely. This is really about solving a problem. We always have to take a step back, I think, and ask ourselves, what are we really trying to accomplish here as researchers, as humans on this earth? And what's interesting about augmented reality is that there are so many different aspects to understanding not just the particular context that you want to use it in, but then also if you get more technical, aspects of human perception and computation, right? Including computer vision. And then also just being able to to understand and evaluate the real effects of what you're building, how it actually impacts people in real life.
Got it. And Jamie, you were going to add something?
Yeah, I completely agree as well. It's super important that we don't design technology in a vacuum, and that we, you know, I think we made the mistake with the original HoloLens of designing this amazing, you know, piece of technology, but it wasn't really useful for very much because, well, I mean, partly we were trying to innovate and create something that hadn't existed before, but you know, as releasing that and getting that out in the real world, we found that, yeah, you know, there are all sorts of things that are missing from this that aren't what we've provided. And so when we were sort of redoing things for version 2, it was very important to sort of get deeply engaged with all sorts of customers and partners to see what it was that they really wanted.
Got it. So I'll just add one more follow-on question. So Jamie talked about how there have been great advances in synthetic data generation. And at the end of his talk, he brought up some of the impressive advances in GAN-based synthesis of human faces and so forth. And this is the tip of the iceberg in terms of what could happen with simulation environments, which could involve agents with different levels of expertise and so forth. And as I look at these different domains, for example, in home repair assistance or the grocery store environment, there are so many opportunities to create these synthetic environments. So you can do sort of a flight simulator, you know, however many thousands of hours kind of thing before deploying it. But then there's also as many opportunities for us to just fly away into our computer vision bubble and forget about real users. So I know when Jamie was talking about the incredible benefits of the synthetic data, no noise, perfect labels, it's just intoxicating. But maybe starting with Flora, could we get some perspective on how your philosophy around using synthetic data, for example, in the stream or front door setting?
Yes. So to be honest, I'm a big fan of synthetic data, and at the beginning, I was telling my team that, you know, we will go full on synthetic data, and we never want to label anything. And we did try to use synthetic data for some of our machine learning models, and quickly realized that they look nothing like real customer homes. And so in real houses, you have clutter, you have washing machine in tight spaces, in cupboards. And we quickly realized that synthetic data is important, yes, but you need to capture some real data in order to give you some direction on like how you will go about capturing synthetic data that represents or that has big coverage. And so, yes, synthetic data is important, but I think that it's crucial to kind of not just go in and start generating it, but have a good understanding of like the distribution you want to represent. And that's why I really like Jamie work on like motion capture before they then went ahead and build synthetic data, because they knew what they wanted to capture. And so that's what I think on the subject. Yeah.
Yeah, any other thoughts from the panel on that? Yeah, Jamie?
Yeah, I would add, I mean, I agree with what Flora said. And I think there's a bunch of different scenarios and complex levels of complexity. And actually, in some respects, humans are easier than environments because they're a fairly closed class. We kind of understand the distribution of things. Of course, you know, there's this sort of long tail of you know, crazy clothing and hairstyles and things like that that are going to be very hard to capture. But you can get sort of 99% of the population relatively easily. Whereas, you know, in environments, yeah, there's clutter, there's sort of almost infinite variation. And so sort of the results I was showing are very, you know, we've been lucky in that we've been able to avoid a lot of that. We haven't had to worry about the background, for example, in our hand tracking, because we can segment that out using depth.
Great, Steve, and then I'll let Andrew take ask a question. Go ahead, Steve.
Sure. I was very inspired by Jamie's results on synthetic data and many others. I think just kind of one kind of funny point here. When I first joined, started working as a researcher, I was between computer vision and computer graphics, and basically computer graphics was this like glitzy, awesome kind of research area that everyone wanted to be part of, and computer vision was this sort of like in the weeds, strange, weird academic thing. And it's basically, computer vision was a way to create models for computer graphics applications. And it's funny that it's now completely turned around, where computer vision is, booming, and computer graphics in many ways is, a way to create models to train computer vision algorithms.
Yeah, it's a very strange reversal that's happened. So Andrew, either a question from you or maybe pull one from the Q&A.
Sure. I want to ask a fairly practical question that relates to all the topics that the speakers touched upon. As we move further into these sort of either wearable or potentially permanently placed contraptions like slow glass, how do we think about compute and networking? Jamie mentioned that 5 years ago they built algorithms that required heavy GPUs, and duct taping them to someone's head wasn't an option, so they had to re-engineer a lot of things. So going from very expensive deep networks that require heavy compute to rendering pipelines that also require tremendous compute, how do we think about bringing these technologies and products to mass markets without being able to control a lot of the hardware and network speeds? Maybe Jamie, you want to start? Sure.
Yeah, great question. Yeah, and I think when it comes to any sort of head-worn device, we're always going to have fundamental sort of thermal limits. That's one of the biggest constraints with putting things on your head. Now, the good news, though, is likely that as network speeds increase, as things like 5G start to appear and mature, that it will be increasingly possible to offload some, at least, of the compute onto the edge or indeed the cloud. We've got an example of this with something called Azure Remote Rendering already, where you can sort of visualize, I think 100 billion polygon, I can't remember the exact numbers, but very high poly count models that couldn't possibly be rendered on the GPU of a device like a HoloLens in the cloud, stream that back, do some late stage fix-ups to do with sort of head motion, and since you sent your head pose over to the cloud and the latency in that. And I think, and it works remarkably well. And I think that kind of hybrid of on-device in cloud is going to become increasingly important. Furthermore, I think as you get into thinking about communication scenarios and virtual presence, well, there you're going to have to go through the cloud or through the network at least anyway to enable the communication. And there you don't even have to incur any additional latency. So that gives us a huge opportunity to offload potential compute into the cloud, but comes with privacy concerns. We've got to, think about, what that means for and what people are comfortable sharing. Are they comfortable with their eye tracking images going to the cloud, for example? It's not something we do today, but would we have to do that for something in the future? I don't know yet.
Very interesting. Anyone else?
Yes. So because we are dealing with remote AR, we already have a cloud component to what we do. And so all the data that we are passing through goes through our cloud. So we can decide to, some of our solutions are actually deployed on the cloud. And so we already have this hybrid set of solutions where part of it runs on a device, part of it runs on the cloud, depending on privacy reasons, or just, if you need bigger compute. And so I just think that as time goes by, as you get more, as the devices get more compute, we can start kind of pushing some of these onto the device, because to be fair, this lower the cost of our servers. And so, so I'm kind of excited about the future where you can have things like meshing running compute on the device, because well, you don't, for privacy reasons, for instance, and then have more complicated things like say mesh texturing happening on the cloud, because actually the person who needs the texture is a pro, and so you can just do the texturing somewhere on the cloud before you reach the professional user. So for us, we are already doing that, and so we'll just be doing more of that in the future.
Great. So I'm going to distill some of the questions from the Q&A board. So let's take the two environmental challenges of outdoors and large space. So I think of necessity, a lot of AR technology has been developed in a kind of office or single room home setting. And I've seen some questions come in saying, how are we going to tackle the challenges of saturated daylight outdoor conditions, as well as things which certainly in the age of pandemics and trying to run conferences where you have very large areas. So can anyone address those challenges, either the outdoor or the large spaces problems? And, you know, a possible answer is it's hard along all the same axes. And it's just a matter, you know, anything anybody wants to know about, like how to make it real time, low latency, you know, the reasonable weight, like all those things, maybe they just simply get harder along every axis. But just curious if there are any other thoughts on that.
I think you mentioned conferences on the sort of large spaces thing. I think there's I don't have any answers here particularly, but there's an interesting, if you think about, you know, taking CVPR fully virtual, either in virtual reality or to a greater extent in augmented reality, you get into really interesting questions of, you know, you've got like lots of, many, you know, hundreds or thousands of participants joining. How do you, I mean, back to compute again, how do you think about, you know, affording the render time for, you know, those thousands of people potentially in your view? How do you lay them out, right? In VR, maybe this isn't such of a problem, but if you've got an AR device, you've got real world constraints. You make the people small so they'll fit in your space. Even sort of starts to hit you with relatively small group gatherings, right? You know, I've got my office here, but you know, if I got more than about 5 people in here, that sort of full virtual human size, it would start to feel very cramped very quickly. So lots, I don't, as I say, no answers, but loads of really hard questions for us to solve. Yeah, Steve?
Yeah, I think for VR specifically, one of the interesting things about VR is scale, right? It lets you appreciate scale in a way that you don't get through small displays, because you look up to see something giant. And so I think that's, you know, for AR as well, you know, that's an opportunity actually, being able to create structures and things and objects which are larger than what you'd be able to manufacture easily or deploy. So I think it's an exciting opportunity.
Cool. So let me I'll start with an informal poll and then ask us to look into our crystal balls. So suppose that this workshop were held with VR headsets. So we just asked you all to wear an Oculus Quest or something and just, you know, for the whole morning session to give your talk and so forth. And so you could do that, or you could use Zoom. Zoom would be the fallback. So how many of you would choose Zoom in that set of options? So at least 2.
I
okay,
would as well.
I can't see Shiri. Go ahead, Shiri.
I would use Zoom.
I probably would too today.
Right, but it breaks your heart, right?
Mm-hmm.
Okay, so can you comment on what, in your opinion, what are the top 2 things that would need to change so that 1 year from now, when we're doing this, we're all wearing this kit and it's somehow everything changed and we're attending this workshop. Well, I want the pandemic to end, but suppose it doesn't. What would have to change so that you do feel comfortable in this exact setting, but wearing an AR or VR device? I mean, I have my opinions, but you're the real experts here. Go ahead, Steve.
Sure, I'll go first. I think, you know, I think part of it's convenience, right? You know, and comfort. But I think ultimately I'd like seeing real people, you know, like the videos add something. I just taught a class online for the first time, you know, this quarter. It just ended last week. So this is fairly fresh in my mind of teaching a real class versus a Zoom. And definitely I miss a lot of things about the real class. But I don't think I'm quite ready to have like avatars, student avatars, or, you know, avatar participants versus being able to see images. So clearly, you know, it'll get there with, you know, for example, the work that Jamie presented and, you know, and Flora alluded to, but I think it's not there yet.
Any other thoughts on that?
I can answer.
Yeah.
I agree that the first thing that comes to mind is probably comfort. The devices are really heavy and large. For me personally, it's too large for my head, and I think that part of that is because is due to gender differences. And I think that with a lot of technologies, they're designed and evaluated through the design process by men. But also, there's a lot to sitting in this room where I am right now and being able to, you know, get the natural light from the window and see the trees. And I think that perhaps this goal of completely putting us in this virtual world is stripping us of these very basic human needs that we have. And maybe the direction we should be moving towards is augmented reality, and maybe looking at how we can virtually add people to the spaces that we're in without taking away from the environments that we can appreciate.
Yeah, I mean, I completely agree with the comfort being the biggest barrier, but also I think that to support what Steve said, is you don't want to be looking at avatars, you want to look at real people. And so to that extent, the environment itself is not that important because we have virtual backgrounds in Zoom and they've been working quite well and they've been very popular. So if you could reduce the size of the headsets and capture humans in such a way that, you know, you could have in AR, you could be looking at real humans in maybe a virtual background and see how the feeling that you can kind of, you are looking at a real person. I think that would be those two things, volumetric capturing of humans or neural rendering, like the one Jamie talked about, combine that with comfortable headsets. I think that the next year, if you had that by next year, then I will be, I'll be pleased to use that for the workshop.
Great. Andrew, you want to take the next one?
Sure. Jamie, did you want to comment?
Yeah, just a quick one. I think one observation that's been really interesting for me during the pandemic is that, you know, everyone is now at home and sort of joining with their video call into these things. And that makes this medium work much better than it used to, when you might have one or two people joining a call remotely, but a large group in a conference room, for example. And it works so much, you know, 2D video conferencing works so much better. It's not perfect by any means, but it works so much better in this symmetric setup than it ever did in an asymmetric setup. Where I think you know, virtual presence in augmented reality and virtual reality may really help is where you do have, especially augmented reality, where you do have asymmetric setup. So you might have a conference room with, you know, several people sitting around it, wearing a headset, and you know, other people who are remote joining in, but they can be seen and feel like they're a real part of the conversation. And so I think that's one of the big opportunities once things start getting a bit back to normal that we're going to have to go after.
Actually,
great, thanks. Go ahead, Serge.
Picking up on the asymmetric factor, when we look at the stream use case that Flora described, it seems like an opportunity for an asymmetric AR/VR deployment, because on one hand, you have a customer who may not have particularly sophisticated AR/VR gear, so they have a sink or a appliance that needs to be repaired, and then you have a professional repair agency that could have substantial AR/VR equipment. And so I haven't thought through the whole workflow here, but I just wonder from Flora's perspective, do you see opportunities for very different AR/VR experiences for the customer and the repair professional, for example, in that case? Or in the case of Shiri, if you think about the person who runs the grocery store as opposed to the low vision customer. I'm so used to thinking of things in terms of the same experience for all users, whereas right now, the hosts of this Zoom meeting have different functionality available to them than the attendees. So I'm just curious what your thoughts are on that asymmetric experience.
Yes, I mean, that's a great question. So as today, we have two separate types of applications for customers and the pro. So yeah, we already have that in place because the customer really just wants to show the video feed and they are just a consumer of the augmented reality experience. And that is actually run by the pro. So the pro has more expertise. They've maybe had more training around AR. And so they're able to add content, to manipulate content, and to guide the user towards what they want the customer to pay more attention to. So I think that, I think that the way forward is not to have one application for everyone, because people have different needs, different use cases, just different knowledge about AR. And so I think that it's crucial to have different experiences and different type of designs for these users.
Great, thanks. Any other thoughts from the panel?
Yeah, I just wanted to amplify that and say it all goes back to the use case, really. So we always start by thinking about who's the target user, what is the scenario, and what are their needs. So as a result, you know, you design the experience based off of that.
Great. I'm going to take another question off the Q&A panel, Q&A board. So it has to do with what I think is a very old question about whether to put all the hardware into the device that you wear on your head, or into a PC or a belt pack or a puck or backpack. So I think many companies and startups have struggled with that question. Where do you put the hardware? And I'm just curious if you can comment on pros and cons of those different choices. And again, I think that the asymmetry is probably a factor here. Also, I think we have some noise coming through the background on, yeah. Okay, so yeah, any thoughts about where to put, what's the right place to put the hardware as we struggle with all of these usability questions?
Yeah, it's a hard one. I think, you know, we've struggled, we with HoloLens, we ended up putting it all on the head. And in many respects, this is great. You know, you have a self-contained device and there's no wires, and I just stick it on my head and away I go. I can walk around. And so that comes with all sorts of goodness. Of course, there's a cost, right? There's a cost in weight. There's a cost in power. There's a cost in thermals. There's a cost in development time in terms of, having to optimize things. And so I think, the longer term direction of, shrinking these things down to smaller and smaller, pairs of glasses and maybe one day contact lenses and things like that. Clearly we can't have all of the compute remaining on there. And so we're going to have to offload it somewhere. Maybe that's another local device. Maybe that's on the edge. Maybe it's in the cloud.
All right, go ahead, Andrew.
Cool. I think we have time for one more question, and this one touches upon photorealism of the data that's being projected and presented. And I see Steve is excited about this a little bit. So one of the things that I've been noticing a lot is that when we deal in particular with human interactions, there are a lot of things that can be improved about each and every one of us, from the appearance to the ability to convey messages, present each other, ourselves, and generally interact. So when we do AR, VR, do we want to use machines to improve ourselves, or do we want to literally transport pixels from, FedEx them from one end to the other and see them in their, with their blemishes and imperfections? Or do we want to improve people, both sort of semantically and visually? You want to start, Steve?
Sure. I think it's a fascinating question, and it's not at all obvious, right? So when I think about how I communicate these days, in some ways, we've gone from, phone to like video, but actually very little of my communication is video. Much more of it is like text and email. So in some sense, we've gone down in sort of like shorter, more episodic, like simpler forms of communication. So will the future be all like 3D and photoreal and, all together? And I think definitely that'll have a, there's nothing replaces, human contact, and, so there'll be a place for that. But I think I'm really excited to sort of see what the next breakthroughs in communication will be. And I think some of them will be, will not be photoreal. And some of the most exciting ones will not be. So I don't know what those are, but I think it's an exciting area.
Any other comments from the panel?
I can add a bit on that. So in the context of utility AR, where you're actually using AR to solve a real, like a problem, an important problem in a customer home, being able to have photorealistic rendering is not that important. Actually, it's the capturing of the environment that's important. But in terms of what you overlay in the environment, that could be as simple as a 3D arrow, right? It just needs to communicate the right information between the customer and the professional expert. And so I think that would depend. It depends on the use case. There will be applications where you need photorealistic rendering, but I think that in some cases it would just be a distraction. Sometimes just abstracting the information is the best way of conveying it. And so in our context, we've seen that, just simple renders work best for our customers and our experts.
I think this is all the time that we have for the panel. So I'd like to thank all the participants, virtually and not. And I think now is the time for a lunch break, and then we'll reconvene in 30 minutes. Thanks,
great. Yes, thanks again very much, not only for your presentations, but for staying on the panel.
Awesome, and thank you for organizing it.
Absolutely.
Cheers.
Hope to see you in the afternoon for the VR. All right, see you later.
Bye.